Okay, this is Ed teaching at Suncoast Technical. This is our lesson plan, but we're actually going to do two operations. This is some of our Titan 1M parts. We got Titan 2Ms, and some people are working ahead. We've been doing engraving on the back. These are manually programmed. Whatever design you want to put on the back. But in this case, we're going to do two operations at the same time. So he's cutting some more material. We're doing a 6M. We already have some that were half done, so this will be a good example. And of course, a common problem is cutting parts that are too short. Like some of these are too short. Don't be too exact on cutting the material. Be always on the plus side. Alright, so our tools are set up. Program is ready to go. We already made one part, so we're going to run this as normal. So this has got G54 and G55 in here. So we have this is half finished. This is our job for this side. This is how we get to the we're doing center of part, and top is finished part is 0. And we put a engraving there of how to get from here to there. Over here we're using the standard left-hand stop, and these are our step jaws, those steel step jaws. Well, while we're at it, we'll go over some other jaws and parallels. The Titan draw here. We have a 9M, we have a 8M, this is 7M. I gotta finish the engraving on this one. We also have our Titan toolbox. We try to keep them assembled, but backup tools. This is our book we have at the machine. It says setup information. So we're actually on the 3M setup is the same. We've added a note here, so we'll update the print. So we're now on 6M. That's the 4M jaw. 5M. 6M. 6M's here. Setup sheet. And we're following these exactly. Right here. Cut to 2.05, so not 2, not kind of close to 2, plus 2.05 plus 2.1 would be very good. Probably if we did the move in 50,000, it would probably change this to 25 and 25. I think that would ensure better setup. And we got all our blueprints, and then we run there into Titan 7. Okay. Okay, so we got Caleb's got a new part here. We'll load it in. We also have our Suncoast 123 block. Advanced actually did the laser engraving on this solid one. We use this a lot for the second operation setup. Okay, ready to go. Okay, let's the only tool we need to worry about is the one we just added, the 1/4" end mill. So let's put it on 50% rapid, and optional stop still on, okay? So cycle start. Well, this part we've already proven out. We've proven the whole job out. Now we're actually going to do both sides now. Go to this side, got the other side. We're using a little bit better feeds and speeds, running 47 inches a minute. Nice light cut at the end. Okay, optional stop is on. Now put on 25% rapid and single block this one down because we just added this tool in. We got our position on. Going to switch to G54 work. Alright, single block that one over. Bring it down. Stop right about there. And what we got there? It says 1.3914 above 0. So if we go in here and look at that, that looks almost like 2 inches almost. Okay. Alright, I would accept that as okay. And take single block off and let this one cut. So this one we're at 8,000 RPM. This machine only is stopped on caps out at 8,100. We're doing 24 inches a minute. Right. And Caleb actually has done some calculations. He knows he can go more on the feed rates. He's experimenting here, and it's at 40. What was the upper number figure?
Like 90 or
90? Okay. And also whatever optimal load we're using for the adapter. This is the kind of sound that I like. And this is a small end mill actually, so probably a little lighter on optimal load. So it's kind of a balancing act. More optimal load, less feed. You know, if you do a quick time study, they may be about the same, or one may be better than the other. But from a load meter perspective, it's very light, but this tool's on the small side. I don't think the load meter would play too much into it. When I edit this, I could speed up this section. We're still at 43, still adaptive, and the retract feed rate is at 180 now. So I've actually moved that up to 400. On the adaptive non-cutting. I had to make myself comfortable with it too. Yep, this one takes a little longer than you think. That small tool. So maybe the 3/8 tool, the rough, and the quarter, the finish, that might be a little faster. Getting there. After this should go pretty quick. We're near the end. Alright, so now you can take optional stop off because you've already proven out the rest of the program. Let's put on 50% rapid. The whole point of the two vises is to have complete parts coming off the machine. Load the raw material on the left side and pull finished material off the right side. Or if you have a smaller machine, you can get a double vise that takes like the same space as one vise. But the single vise is a little bit easier to set up. Now we're doing G73 pec drilling actually, using the 4-inch tool to create the holes. See the short pecs. This is the G83 pec cycle. A lot quicker system. Now we're over here. We're utilizing the tool on both sides. It'd actually be nice to chamfer the holes, but then you'd have to design a jaw that would orient. We'll just hand rework those. Drill. Tapping. Oh no, engraving, sorry. With air blast. So we've added engraving. We actually followed a video online how to use stick font with the SHX font. And we're using a ball end 1/16.
Going over it a second time actually like made it
way better.
Nice,
yeah. I think we accidentally made it do it twice, but it actually came out better. So. Engraving can be time consuming, so I'm putting in an order for an air turbine spindle, 30,000 RPM spindle or 40,000, so this should be like 5 times faster or any of the small detail work. Because we're running this right at the max RPM. Alright, and last one. So this one, we've got 200 RPM. I think we've been running a lot of them at 5, and I think somebody accidentally had it on 1,000, so that all worked. Speeds for taps can be more experimental than anything. How far can you spin it, and how good is the tap? Now we have fully finished part, end of program. So we got operation 1. And operation 2. Let's take a look at that one. Pull that one out. Alright, so that's complete. And these are the ones we had. So if you're setting up a job like this, you would just run it with one side only, and that's what now this is with. I think this
break.
Well, I was looking at it in the job. These are the ones that were done previously. You see that? That's one of your parts.
Yeah.
This part's too small. But that's all right. These are what we call setup parts. So this is proving out our project. So, yep, good text. All right, thank you. That's real good.